Hello and welcome back to Ali Khan Maths. In this video, we're going to be covering the concept of logarithms. Logarithms build on your knowledge of exponents and the laws of exponents, giving you another way of solving different types of equations. They can also be used to model many real-life situations, such as the population growth of countries or interest rates. In this video, I'm going to be going through what a logarithm function actually is, as well as the different logarithm rules and how you can use them in solving questions. If you aren't very familiar on the rules of exponents covered at GCSE level, I highly advise you to check out my exponents playlist, which will be linked in the top right corner and in the description below, which will cover everything you need to know to have a solid foundation for A-level logarithms. So, what actually is a logarithm? To people who haven't encountered it before, a logarithm, or log, might just be that button on the calculator that they'd never use. However, you have to understand that a logarithm is a function, and it's usually referred to as the inverse function of exponents. For example, these two expressions are just different ways of writing the same thing. 2 to the power of 3 equals 8 can also be written as log base 2 of 8 is equal to 3. The log function, by definition, is essentially asking 2 to the power of what number is equal to 8? And of course, in this case, that's 3. You can verify this is right quite simply by plugging it into your calculator, and you should get 3. Now, this expression containing the log function actually has 3 different parts. It's not necessary to use these names on a regular basis, but it's helpful to know them. This part is what you do need to know, and this is called the base. So you'd quite often hear logs of different bases, of base 2, base 3, you can have a log of base e, which is also known as the natural log. We'll come to that later. So this is known as the base. This is the argument, and then this part is the exponent. It can take quite a bit of getting used to in trying to write what you've traditionally seen as normal exponents into log form, so I'd advise you to just take normal exponents that you're familiar with and try writing them in log form until you get an understanding of which numbers go where. So, for example, 3 to the power of 4 is equal to 81. Can be written as log base 3 of 81 is equal to 4. And you can check that by putting it into your calculator once more. And it's this logic which can help us solve the first type of logarithmic equation which we're going to encounter in this video. This is probably the most basic type, where you have a known base, an unknown exponent, and you know what the answer is. So in this case, if you write 7 to the x equals 4 in the same logarithm form that we found, you find that x is equal to log base 7 of 4. By putting this into your calculator, you should get an answer of around 0.712. I encourage you all to pause the video and try solving this equation by putting it into log form and then into your calculator. You should get x is equal to log base 2 of 1024, which should just give you 10. So we've learned that logarithms can have different bases depending on which exponent they represent. For example, the logarithm of base 2 represents the inverse of any function of the form 2 to the x, or 2 to any power. There are a few special logarithms with special bases that are used a lot more often than others in maths. The first being the log base 10, which is known as the common logarithm. And sometimes this is just written as log. The other would be log base e, or Euler's number, which is written as ln, or the natural log. It's important to note that you can use these logarithms to solve exponential equations such as the ones we've seen so far. You need to know the different logarithm laws, which can be used to manipulate logarithms and can really help you solve equations. This first law involves when you're adding logarithms of the same base, as you can see indicated by the a's. So if you have something of the form log a of x plus log a of y is equal to log a of x times y. So for example here, the bases are the same with base 2, and we're adding log 2 of 5 with log 2 of 7. So according to this law, our answer should multiply 5 times 7 to get log 2 of 35. Now this second law feels quite like a reverse of the first. The bases are still the same, except this time you're subtracting the logarithms. And here, if you have log a of x minus log a of y, your answer is going to be log a of x over y. So you're dividing these two numbers. In this case, log 3 of 6 minus log 3 of 2 is going to be log 3 of 6 over 2. 6 divided by 2, which is going to be 3. The third logarithm law is arguably the most important out of all of these in terms of which you're going to be using the most during questions and in the exam. So it says if you have a log of an exponent, in this case x to the m, what you do is you bring the exponent to the front and you multiply that out. So you have log a of x to the m, you would bring the m to the front and you just have m times log a of x. In this example, log 2 of 3 cubed would mean you bring the 3 to the front, giving you 3 times log base 2 of 3. Now, aside from those three main laws, here are three other things which are more like special cases that would be very useful for you to remember. So for example here, log a of 1 over x can be written as x to the minus 1. And then from there, you just use law number 3 of bringing the exponent to the front to get minus log a of x. This is one which makes complete sense if you think about the actual definition of the logarithm, which we discussed at the start of the video. So this would be the same as talking about a to the 1 equals a. Similarly, log a of 1 is equal to 0. Again, if you look at the definition of the logarithm, anything to the power of 0 equals 1, so this also makes complete sense. It's important to remember that in all of these cases, a can mean anything, but in the first three rules, your bases have to be the same. So far, all of the rules we've looked at have been relating logarithms which have the same base, but there's ways of changing the base of the logarithm. Part of this involves looking at what we call the common logarithm earlier, or just log. So remember that log is equal to log of base 10. It's often preferred to deal with logarithms with log base 10 and then convert to other bases after. And you can do this with the following identity. So any standard logarithm, for example, log base a of b, can be written as log b over log a, remembering that log is just log of base 10. You can test this out yourself using your calculator. Taking the log of base 2 of 5 gives you 2.32, and if you take log 5 over log 2 by the identity, you get the same answer of 2.32. This is something you'll see me referring back to quite a lot, as most logarithms are easiest to work with the base logarithm of log base 10. Number 5 is another useful rule for changing the base of a logarithm, where you have log base a of b is equal to 1 over log base b of a. And this is illustrated by this example, and putting this into your calculator proves to you that the same answer would be given of 2.32. Final rule is a variation of a log base change. If you have a power in the base, you can take that power, take the reciprocal of it, and multiply it by the rest of the logarithm. It's best illustrated through this example. If you have log base 8 of 3, 8 can be written as 2 cubed, and by this rule, take the reciprocal and write 1 over 3 log base 2 of 3. Using the logarithm laws and the base conversions are absolutely essential in covering all logarithms questions, from the most basic to the most difficult. I highly encourage you to rewind the video if required and look over all of the different laws until you fully understand them and have fully memorized them as well. I'll go through a few examples of how you can use the laws and the base conversions to simplify logarithms. So take this first example, log base 2 of 8. 8 can be written as 2 cubed, so we can write this as log base 2 of 2 cubed. And now, from the logarithm law number 3, when we have an exponent, we can bring that to the front. So instead, this can be written as 3 times log 2 of 2. Now, from one of our identities, we know that if the base and the larger number are the same, this is just equal to 1. So this is equal to 3. And again, this makes sense if you think about it from the definition of a logarithm point of view, where 2 cubed is equal to 8. So log base 2 of 8 should equal 3. Now let's take a look at another one. Here we have log base 27 of 3. Now 27 can be written as 3 cubed. So you can write this as log base 3 cubed of 3. Now keep in mind this cubed is part of the base. Now from the last base conversion rule we used, which was rule number 6, we can bring this exponent to the front and take the reciprocal of it. So this is equal to 1 over 3 log base 3 of 3. And now from the same rule as above, when the base and the larger number are the same, this is just equal to 1, giving us 1 over 3. In this example, we can write this expression as log base of 7 of 2 to the minus 4. Now, from rule number 3, we can bring this exponent to the front. I did mention we'd be using it a lot. So this becomes minus 4 log 7 of 2. And this is something which cannot be simplified any further. Now if you put this into your calculator, you should get an answer of minus 1.42 approximately. Finally, if the question asked you to convert this into a single logarithm, you would use the base conversion rule number 4. So here we have log of 5, also known as log base 10 of 5, over log of 3. And by rule number 4, this can be written as log base 3 of 5, and this should give you the same answer. So to recap, in this video we covered what a logarithm is, how you can write exponents as logarithms, and the different logarithm laws and the base conversion laws. It's important to memorize these and understand how to use them so that you may be able to solve the easiest and the most difficult of algebraic logarithmic equations. My next video will cover how to apply all of these logarithm laws in the questions you might expect to get in a textbook or exam, so that you can actually use these to solve equations. Please remember to like this video and subscribe to my channel to make sure you never miss an upload. Remember to share this video. It not only would help other people in understanding this topic, but it would also really help my channel grow. Thank you so much for watching.